In today's video, we are going to discuss next few questions of the chapter, some basic concepts of chemistry. The first question is question number 10, and the question says, in 3 moles of ethene, that is C2H6, calculate the following. First one, number of moles of carbon atoms. Second, number of moles of hydrogen atoms. And third, number of molecules of ethane. We know that 1 mole is defined as the amount of substance that contains as many particles, which can be atoms, molecules or ions, as there in carbon-12 isotope. So here, in this case, 1 mole of C2H6, that is ethane, will contain 2 moles of carbon atoms because there are 2 atoms of carbon. So we can say that 1 mole of C2H6 contains 2 moles of carbon atoms. Now it is asked in the case of 3 moles of ethane. So what if it is for 3 moles of ethane? We have to multiply this with 3. So we get 6 moles of carbon atom. This is the answer for the first question, that is the number of moles of carbon atoms. Similarly, we know that in 1 mole of C2H6, we have 6 moles of hydrogen atoms because there are 6 atoms of hydrogen. So according to the definition of mole, we have 6 moles of hydrogen atom. Now we have to find in the case of 3 moles of ethane. We multiply it with 3. So 6 into 3, that is 18 moles of hydrogen atoms. So this is the answer for the second question. For the third question, it is asked to calculate the number of molecules of ethane. We also know that there is a concept of Avogadro number. So this Avogadro number can be defined as the number of particles present in 1 mole of substance. So here, in this case, if we have 1 mole of ethane, we know that this 1 mole of ethane is exactly equal to Avogadro number of molecules. So that is 6.022 into 10 power 23 molecules. Now we have to calculate for 3 moles of ethane. That will be 3 into 6.022 into 10 power 23 molecules, that is 18.06 into 10 power 23 molecules. Hence we calculated the number of molecules of ethane. So the concepts that we should be aware to solve this question is the idea about what 1 mole is and how 1 mole is related to the Avogadro number of molecules. Question number 11 says, what is the concentration of sugar, that is C12H22O11 in moles per liter, if its 20 gram are dissolved in enough water to make a final volume up to 2 liter? So here in this question, we are asked to calculate the concentration of sugar in moles per liter. So we have to calculate the molarity or the molar concentration. We know that this molarity is equal to the number of moles of solute upon volume of solution in liter. We already know that the volume of the solution is 2, which is given that it is 2 liter. So we know that this volume of the solution is 2 liter. Now we have to calculate the number of moles of solute. The solute here is sugar, that is we have to calculate the amount of sugar dissolved in the solution. The number of moles of solute, I'll write here as sugar, is given mass of sugar upon the molar mass of sugar. The given mass, which we know that it is 20 gram. Now we have to calculate what the molar mass is. Molar mass, here it is 12 into, since there are 12 atoms of carbon, 12 into atomic mass of carbon is 12 plus 22 into 1 plus 11 into 16. That is 11 atoms of oxygen and 22 atoms of hydrogen. This is giving us a sum total of 342 gram per mole. So this is the molar mass. Now to calculate the number of moles, we have 20 given mass, 20 gram divided by 342 gram per mole. And this is giving us 0.0585 mole. Now, to calculate the molarity, we know we have calculated the number of moles of solute to be 0.0585 moles divided by volume of solution is 2 liter. And this is giving us an answer as 0.0293 moles per liter. That is the final answer. This can also be written as 0.0293 molar. Moles per liter is similar to molar. Question number 12 says, if the density of methanol is 0.793 kilogram per liter, what is its volume needed for making 2.5 liter of its 0.25 molar solution? From the question, we know that density of methanol is 0.793 kilogram per liter and density is mass by volume. In this question, we are supposed to prepare a solution which is having 2.5 liter of 0.25 molar solution. If we use the equation of dilution, that is M1V1 is equal to M2V2, where M2V2 stands for the solution to be prepared and M1V1 for the given solution, we know that M2 is the concentration of the solution to be prepared, which is given as 0.25 molar, and the volume, it is 2.5 liter. So here we are going to calculate the molarity of the given solution, that is M1. To calculate this molarity, we should know number of moles of solute divided by volume of solution in liter. This equation can also be written as number of moles of solute as mass of solute divided by molar mass into this volume of solution. So here we are going to calculate the molar mass of methanol. Methanol, it is CH3OH. So it is atomic mass of carbon plus 3 into atomic mass of hydrogen plus atomic mass of oxygen plus atomic mass of hydrogen, which is giving us 32 gram per mole. Since the density which is given to us is in kilogram per liter, we are converting this gram into kilogram. What do? We are dividing it. So we get it as 0.032 kilogram per mole. So this is the molar mass. So the molarity of the given solution is the mass of the solute by volume of solution in liter into molar mass. Substituting the value, mass of solute by volume of solution is mass by volume, that is density, which we know from the question as 0.793 kilogram per liter divided by the molar mass, which we calculated as 0.032 kilogram per mole, and this is kilogram per liter. Solving this, we have 24.78 moles per liter. This is the molarity of the given solution. Coming back again to this equation of dilution, we have this is for the given solution and this is for the solution to prepare. As I have mentioned, we know that the volume is 2.5 and the concentration is 0.25 molar. This is for the solution that we should prepare. Now for the given solution, we calculated the molarity to be 24.78. Now we should know what is V1. That is the volume of the solution that we need for making this solution. So V1 is, just cross multiply 2.5 into 0.25 divided by 24.78. And this gives us as 0.02522 liter. If you convert it into milliliter, that is, when we multiply it with 1000, we get 25.22 milliliter. So this is the answer for this question. Question number 13 says, pressure is determined as force per unit area of the surface. The SI unit of pressure, that is Pascal, is as shown below, which is 1 Pascal is equal to 1 Newton per meter square. If mass of air at sea level is 1034, that is 1034 gram per centimeter square, calculate the pressure in Pascal. So this is a question of unit conversion. We all know that pressure is force upon unit area and force is mass into acceleration due to gravity. So we can say pressure as mass into acceleration due to gravity upon unit area. Here we are given the mass of air as 1034 gram per centimeter square. Now we are going to convert this into kilogram meter square. How do we convert gram per centimeter square into kilogram meter square? First, let us convert gram into kilogram. To convert gram into kilogram, we divide it with 1000. So we get 1034 kilogram per centimeter square. Now we have to convert this centimeter square into meter square. We know that 1 centimeter is equal to 0.01 meter. So 1 centimeter square will be square of this as well. So that will be 0.0001 meter square. Now we have to convert this value into kilogram meter square. What do? We divide it with 0.001. That gives us 10340 kilogram per meter square. Hence we converted this mass of air which was given in gram per centimeter square to kilogram meter square. We know this force by area, it is 10,340 kilogram per meter square. But here we haven't multiplied it with this acceleration due to gravity. So hence we are going to multiply it with acceleration due to gravity, that is 9.8 meter per second square. So we get the answer as 101332. Now we can also write this as 1.01332 into 10 raised to 5 Newton per meter square. The only thing that we have to be careful in this question is the conversion of this gram per centimeter square into kilogram per meter square. I hope the questions that we solved in this video is clear to everyone. If you have any doubts, you can come and comment in the comment section. Thank you for your time.